So we did things a little bit out of order, so we'll start officially here with the look at the calendar. Today is our last day on voting. It's our 4th day on voting. We talk about something called Arrow's impossibility theorem, which is going to be quite depressing to us. And then we're talking about rankings. We'll actually start there in just a minute. Next class is our review for test number 1. So Thursday is a full period review for the test. At the end of today, that will be the end of the material that is going to be tested 1 week from today. Test number 1 is scheduled for October the 4th, okay? Tuesday of next week is our first test. It's already October. Okay, so that is that. And just in terms of thinking about that test, I just want to point out that, or I just want to give you a sense of what the review is going to look like on, I think I got my days wrong. Today is Thursday. Okay, so the review is Tuesday, and then the test is 1 week from today, next Thursday, okay? All right, so you don't need to go here now, but if you go a couple of pages down the road, it's on page 37, you're going to find these sample test problems. And at the start of our review period, Tuesday coming up, we're going to spend maybe 5 minutes just talking very generally about the test, what you can expect, what resources you can use, and then you guys are just going to go to town in your groups. You're going to find a partner or work with the bigger table and just answer as many of these sample test problems as possible. Now, I don't expect that the hour and change that you're going to have to answer the sample test problems will be enough. I don't think that you'll have enough time to do all of them in class on Tuesday. So if you have time between now and Tuesday, you can start. It is definitely not too early to start studying. Go through as many of these as you can. And just in terms of resources, I wanted to point out that if you go onto YouTube, there's a direct link to this on my syllabus, but I'll just show you how to get there another way. I actually made videos of the sample test problems. So if you type in my username, which is GCCMathWinokur, no spaces, the very first option here is my channel. And inside of here is where you find the daily class videos. So there's the video from Tuesday. But what you're interested in coming up is this word playlists right there at the top. And inside of playlists, you will see 117 there, sample test number 1. And you will find videos of me going through all of those sample test problems one at a time. And if you have a question about problem 3, go to the video for problem 3. You don't even have to watch the whole video, right? It's all broken up for you. You'll hear me. You'll see what I'm writing on the on here. And also, if you go to Moodle, and I don't know if I have this on this computer, but yes. So if you go to Moodle, you'll find a PDF of my solutions to these sample test problems right here in color and worked out not just an answer key, but actually how I did all my calculations. All right, so that's in Moodle. Okay, Patty had a question. Okay, thank you. Yes, one piece of paper, front and back. Anything you want to write on there, that can include like theorems, that can include definitions. You could have explanations of each of the methods. You could have this problem right here worked out in its entirety on your piece of paper. Whatever you need to help you get through that test. Other questions? Okay. Then, so let's go back to where you guys were, which was right here. Now, I know that not all groups finished all of the methods, and that's okay. There was a lot here. Some groups actually ended up divvying up the work, and so we're able to kind of get everything done by splitting it up. So just take my word for the numbers that are here if you didn't get all of them, but we'll start with this thing called, we're ranking the candidates using an extended method. And I'll explain what that means, and there's another way to rank candidates, and we'll do that next. So here's what we have. Plurality method. What are the only votes that count? First place votes. Here are my scores. Who wins? A. Okay, so fair enough. There's nothing new there. A is the winner, so A wins. But now we're interested in who's second place, and who is the very natural choice for second place? C. By having the second most number of points. Who's the natural choice for is B, third place. And then finally, D, last place. The music. Okay, you guys just did something we have not done before, but it's very natural. And it's called an extended method because you take the plurality method normal, and then you just extend it in a very natural way. Rank the candidates based on who has the most points, who has the second most points, all the way down. Easy? Let's come down here to part B. And actually, I realize I didn't finish part B. What do I still need to do after I do all my comparisons? We need the points, right? So A, B, C, and D. Okay, how many wins did A get here? Just one. How many wins did B get? 3. That's pretty good. C, it's 2, and poor D, 0. Okay, so now we've got our winner. Who's the winner of this method? It's B with the most number of points. We stopped there last class. Now we rank the rest of the candidates. Go ahead and write it down. Write down the second place winner, the third place winner, and the fourth place winner. Okay, who's second? Is C with 2 points. Who's third? Is A with 1 point, and then fourth, D. Okay, let's go down to plurality with elimination. Now, this is a little bit sticky for some people, so we're just going to briefly review how we do it normally, and then we'll extend it to rank all the candidates. So the word plurality still means what it's always meant, first place votes only. So we count the first place votes. In fact, you don't have to do it again. You already did it, right? You counted them already. So on the test, I'm going to ask you to do both of these. Feel free to just copy your answer from the plurality method. Okay, so the question is, does somebody have a majority? Majority in this case was 13. Do we have a majority? No. So we eliminate D, last place person. Person with the fewest number of votes, we eliminate D. That means that the votes get reshuffled. It is very common to do something like this. Say, all right, D is eliminated. Now the scores are 10, 4, and 8. And then who gets eliminated? B is eliminated, and now the score is 10, 8. And now who gets eliminated? C. Okay, if you do that, who are you going to find as the winner every time? Whoever had the most votes to begin with, right? If you just eliminate everybody from the bottom up, you're just slowly doing the plurality method. So that's not how it works. If you just cross those votes off and you don't give them somewhere else, then people aren't getting counted. Every vote needs to count. It needs to add up to 25 every time. And if I just do this, it no longer adds up to 25. So we eliminate D. You go back up here and you say, okay, cross off all the D's, but really there's only one D that matters in this case. It's that one. Because those people thought D was the best. Now we need to go to their second choice. So who do those people think is the best now? Is the C. So C gets 3 more votes than it had before. Everything else is the same. So that's what I've done down here. C has gone from 8 to 11. Everybody else is the same. Again, you ask yourself, is there a majority? Nope. So we shuffle around, we get rid of B in this case, and then turns out it's 10 to 15 at the end. And so the only new thing here is to rank these folks. So who just won? So C was the winner at the end. Who do you think is our second place winner? It's A, because they were in the finals, right? They lost, but at least they made it all the way to the end before they lost. So A seems natural for second place. B or D? Who's third? B, because even though B got eliminated, well, they were 1 step away from the finals. So they were as close as they did better than D, right? So when we rank these guys, you just kind of go backwards. Just walk your way back. B is third, and by being eliminated earliest, D is last. Good? Okay, and then finally, the one that's probably the most work is this Borda method. Lots and lots of arithmetic, lots of calculations that you have to do. I'm going to give you one little shortcut, maybe not a shortcut, but a way to check and maybe catch an error. It turns out that if there are 4 candidates, then the sum of the Borda votes, or the Borda points, I should say, has to equal 10 times the number of voters. We'll explain what that means. I'll just give you a second to write it if you want to write it. Okay, so what's going on here? All right, first, I think this is my 6th time teaching this class at GCC. I have never shared this fact with this is just something I'm sharing. It's not part of the course, like it's not required or anything. I'm just giving it to you in case it's useful to you. So how many voters did we have in this case? We had 25. And so what I'm saying here is that if you do 10 times 25, you get 250. If we did this right, it's going to add up to 250. So people with calculators, can you just add up those 4 numbers? Just waiting on some confirmation. 2 people confirmed, 250. And one of the groups that I was walking around with actually had, right here, instead of a 69, had a 59 initially. And if you added those up, you would have gotten 240. And that's a way that if you kind of know this little thing, you say, all right, I don't know where the error is, but there's an error somewhere. Like it's kind of good news and bad news. The good news is you got some notice that you have to fix something. The bad news is pretty much you have to start over and look at every single calculation to try to find it. So I don't know how much that thing is worth. It's kind of a mystery why it's 10. You can see me after class if you want to know why it's 10. But anyway, that's a little thing you can use to check. So all that's left to do is rank these folks. So let's put that up there. So who is first place in this election with the board of points? Okay, so C just won, just barely. That's old. Now the new thing is to rank the remaining candidates. Who's next? B. Third? A. And then dead last, as usual, D. I think I copied this from your book. Yeah. D needs to win sometime. This is just embarrassing. It's worse than D never wins. D is like always last. It's just, I don't know. Okay, so here's an observation. I just want to look at the rankings and compare them. The question is, are any of them the same? So the first ranking we got was ACBD. Second one, BCAD. Third one, it's down here in black, CABD. Fourth one, CBAD. Are any of them the same? No. Which one is the best? I don't know. It doesn't much matter, actually. Really, we just need to acknowledge that how you count the votes completely determines who's going to win the election. Morgan. So if we look at like all the voting methods and then try to put them together in some way and figure out who is the overall most favored, one group thinks C. So Mariah, what did you say about the different methods?
Oh, I said that when you look at them, in the first one, A won, but in the last 3, A did there.
Oh, so A was the winner using plurality, which is how we do almost every election here. But A was certainly not the favorite in any other election. And sometimes A did really badly. A is like the new D almost in some of these elections, right? So, you know, I mean, like, it's just something to think about. I mean, we elect most people in this country using plurality, and we get very different results using like any of the other 3 methods. One thing that so last night I was watching Survivor. Any fans of Survivor? Kinda. You can admit it. It's okay. I'm not proud of this. So what do they do at the end of each episode? So they vote off one person, right? Do they say, okay, I think that you know, like Anthony is my least favorite person, but second least favorite person is Beth, and then third? Do they rank them like that? No. What are they doing on Survivor to eliminate somebody? Which method? That's a plurality vote, right? They're picking their first only. And so I just want to call Jeff Probst up and just say, hey, look, dude, you know, like it's not okay. Like you could change the outcome. It's $1 million. We gotta do this right? Maybe pairwise comparisons or something. Can you imagine that the tribal council sitting there for half an hour? All right. Okay. So, all right. So these are the different ranking methods called extended methods. You do the thing normal, and then you just extend to rank the rest of the candidates. We're also going to talk about something called recursive methods. We're going to do that on the next page, but first, let's jump back because we actually kind of skipped ahead today. So let's start at number 1 here. And can we go to Mike?
Summarize using 4 different methods: count, plurality, order, elimination, or criteria to decide how to consider majority criterion, recursive criterion, independence of relevant.
Well, that's a mouthful. Thank you. Okay, so 8 things. We talked about the 2 tracks with 4 on each track. Those things are all summarized on the first page. Let's go to number 2. Danny. Okay, so let's go back. We had a nice little chart that kind of summarized the 4 voting. Here they are. So the 4 voting methods were on the left, and the 4 fairness criteria were on the top. And what were we looking for? Yeah, we want something that satisfies all 4, and we didn't have any that satisfied all 4. Okay, maybe it's just because we haven't been creative enough. Maybe there's a more creative way to count the votes that will satisfy all of these in every election. And Arrow's impossibility theorem comes along earlier in the 20th century, like mid-20th century, so not too long ago, and it says there is no way to count the votes, no way to count the votes that will always satisfy all 4 of the fairness criteria. This is really bad news, right? There's no way to always make sure you're going to satisfy those fairness criteria. That's unfortunate. It doesn't mean that every election is unfair. It doesn't mean that. Suppose that I asked you guys to list the following options in terms of your preference. On Thursday, 1 week from today, we'll take the test. On Thursday, 1 week from today, we'll have an ice cream party. So you have to choose, you know, like first place, second place. All right, so raise your hand if you would rather have the test first and then the ice cream party is your second choice. Good. Raise your hand if you'd rather have ice cream party first and second choice is the test. Good. No matter how we count the votes, Borda, plurality, any of those things, who is going to win this election? The ice cream party, right? And that's fair. That's the right thing to do. So we're not saying that the outcome is unfair. By the way, we're having a test next week, just to be clear. So we're not saying that the outcome of that election is unfair. We're just saying it's possible to make up some election where the outcome is going to be unfair. There are some elections where the outcome is going to be unfair, no matter how you count the votes. Lucas. Good, good. Okay, so here's a quote that I really like. We're on to Stephanie. Good. Tim, number 3.
This does not mean that all voting methods are completely unfair. This also does not mean that all elections are unfair. But it does mean that you will have to accept trade-offs to choose one election method.
Okay, let's go to number 4, Patty. Can you keep going? We agree? Some people in this room have voted tactically because they thought the candidate that was the best had no chance of winning, and they said, I don't want to throw my vote away, I'll at least vote for somebody that has a chance of winning. And that's not so great, right? I mean, we'd like you to be able to vote with your heart and never get a better option by strategically voting, right? We want to see what your true preferences are. And then along comes this Gibbard-Satterthwaite theorem, which says that basically it's impossible. There are actually only 2 kinds of systems that aren't vulnerable to tactical voting, a dictatorship and a random system. So what does that mean? If I tell you guys that we're going to vote using the plurality method, it's possible for some of you to vote tactically, to strategically vote, not with your heart, but trying to like kind of play the game and say, well, what's the best outcome I can get, even if it doesn't mean voting sincerely. Or I could say, hey, we're going to use the Borda method. Now, some other people maybe could now vote tactically and take the people they really like, put them first, take the people they kind of like but are worried are going to be competition for the people they really like and put them last. And that's not so great. So depending on how we count the vote, different people could vote tactically in different ways. for all of our 4 voting methods, and it turns out for every voting method, there's a way to kind of vote tactically, and that's unfortunate. The only ones that aren't vulnerable to that dictatorship, okay, so if I'm the dictator and my vote is the only one that counts, then there's no point in me voting any other way than the way that I want, right? So I'm not going to vote strategically, I'm just going to vote what I want, and that's good. That's what's going to happen. Or a random system. Suppose that you went to the polls and you voted, not just first place, but you ranked all the candidates. And then after the polls closed, the news folks said, okay, guys, this election, turns out we're going to use the Borda method. Okay, if you don't know how the votes are going to be counted going in, then you can't vote tactically because you could, if you pick wrong, you could end up hurting your candidate more than helping. So, and that's not so great either, right? Where we don't know how the votes are going to get counted until after we vote. So that's unfortunate. But we can look for a system that's less vulnerable to tactical voting. And I think pairwise comparisons generally is sort of the favored choice. Of the 4 that we've looked at, I think pairwise comparisons might be fairest. It's not perfect, but might be the best. Let's go to Melissa for 5. Do we buy that? If somebody loses to everybody head-to-head, they should not win. Fair? Right. Turns out there's some elections that we could cook up where somebody loses to everybody head-to-head, but wins. That's not so great. We'll keep going with the clone one. Morgan? Do we buy that? Seems reasonable. I mean, having it like your twin join you shouldn't change. Like if you were going to win, then you should still win. And if you were going to lose, you should still lose. Shouldn't change anything, having your twin race. Well, it turns out having your twin there in the election could help you or it could hurt you. Suppose that we are going to vote, suppose we're going to do a plurality vote where it's only first place. And suppose that you were going to win this election normally. And then your twin comes in. What's going to happen? The twin is going to take some of those votes, right? We've seen elections where there's like candidates that are kind of close to each other, and probably either one of them would have won on their own, but the votes end up getting split because there are candidates that are near each other, and we can't choose, or some people choose this one and some people choose that one, and they both end up getting hurt. Does that sound reasonable? Right, so in that case, having your twin run against you is a bad thing. But suppose that we're using Borda method. That's where you get points for being first, right? And suppose that there's 4 candidates in the election. You're one of them and your twin is not in the picture yet. For a first place vote, how many points do you get? You get 4. Now suppose that your twin comes in. Now presumably if somebody thinks you're the best, then they're going to think your twin is also the best. So now we have 5 people in the election, and you and your twin are going to be in either first or second place, right? The people that loved you before love both of you now. So now how many points do you get for being in first? 5. And how many does your twin get for being in second? 4. And everybody else is still down there at 3, 2, 1 land. So actually having your twin run with you in a Borda election would help you, right? You guys would get more points and everybody else would be down below. So both of those methods fail this clone independence criteria. We don't want you to get hurt by having your twin in there, and we don't want you to get helped by having your twin in there. Okay, and then this participation one, I think we're back to Alex. Do we buy this? There should be no incentive for you to not vote, right? We want people to go out and vote. Not voting should not help you. Agree? That's fair. All right. Turns out that there are elections that happen all the time where actually not voting is in your best interest. So some town meetings require a quorum, like that at least 10% of every resident of this town needs to be here at this town meeting for this vote to count, just to make sure that enough of the town is represented. Have we heard stuff like this? Okay, so let's suppose that you're at town meeting and you've got like 11% of the vote, 11% of the town is there, and so we're going to vote on this thing, and whatever the town votes, that's what's going to happen. And suppose it's pretty clear that the majority of these people are going to say yes to yes to the ice cream party. But then there's the couple of percent, like 2% of these people just, say, well, I don't want the ice cream party, that's not okay. What might they do instead of voting no when they realize they're clearly outnumbered? They could just leave, right? If they leave, and then there's not 10% of the town there anymore, the vote doesn't happen. And that doesn't seem right. And I've actually seen this happen, like in my town of Leverett. I saw this happen once at a town meeting. And not voting shouldn't help you. So there's a problem with this kind of idea of having a quorum. At least 10% of the population has to be here. Okay, so conclusions, Gary.
Here's the overall study. Otherwise, there's for voting.
Okay, so if I had to ask you guys to take one theme from the last 4 classes, it's that right there. A lot of things are better than the plurality method. So first, if you said to somebody, hey, there's other ways to vote, the first reaction would probably be, what are you talking about? You pick who you want and you hope they get the most votes. There's a lot better ways to vote than plurality. That said, this is a voting season right now. Get out and vote. I'm not saying don't vote to protest. It's your civic obligation to get out and vote. Actually, next week GCC is having I think it's GCC Rock the Vote or something like that. I'll give more details about it on Tuesday, but anyway, an opportunity for you to get registered if you're not, for you to find out where you're supposed to vote, when you're supposed to vote, all that stuff happening next week right here on campus. So more details coming. But anyway, the plurality system is not the be-all, end-all, and in fact, it has a lot of drawbacks. Okay, so on the next page, remember we had our rankings called the extended method, where you just do the election the normal way and then you rank them in the natural way. Now we're going to go on to the next page, which looks an awful lot like the previous page. What's the only difference? This is now recursive. This is the only word that's different on this page. Everything else is the same. Instead of called extended, which we just saw, these are the recursive methods. So let's try it. All right, first thing we do is exactly what we did before. So in part A, it's plurality. What are the only votes that matter? First place. Now we don't need to do all the work again because the numbers are the same as they were before. So what was it, 10, 4, 8, and 3. Okay, so we had that from before. And this is the plurality method, so we just want the person with the most. Who wins? A. Who was second? C was second before. Not necessarily anymore. We have work to do. This is a different way to figure out who's second. So you don't just go down the list like you did before. What you do is you say, okay, A has already won. We're actually going to cross A off because they've already won. Now, I don't need you to mark, like I'm going to mark that thing up a bunch of times and erase it. So just be careful if you decide you're going to mark it up today. So A has won. So they're out of the election. Now how many candidates are in this election? 3. And we're actually going to run a brand new election. So B and C and D. First place votes only. A is out of the picture. Can I just copy those numbers, 4, 8, 3? The answer is no. Because, for example, these 6 people, who did they think was the best? A, and they won. That's great. Who do they think is the best of the remaining candidates? Is B. So B doesn't have the same 4 votes. B has more, right? Everybody gets pushed up. So let's count some votes here. So I'm just going to write this out. Let's see. B gets those 6 plus. Who gets the next 4? B, because A is the winner and D is the next. So this is 4 down here. Who gets the next 4? So B gets those. The next 4 is C. The next 4 is C, and the last 3, D. So these are my totals here. 10, 8, and 3. Sorry. 10, 8, and 7. I was thinking about Survivor again. I apologize. 10, 8, and 7. Okay, this is a brand new one-shot only plurality vote. Who just won? B just won. So I'm going to say B wins, but what do they win? They win second place. Right? B is our winner, and by being the winner, they win themselves second place. And now what do you think we're going to do? Now we're going to cross off the B's. And we're going to run a brand new election. I think some people are already predicting D's demise here. We'll see. Okay, C and D. I get 18.7. Okay. So who just won? C wins third. And so who's fourth? B, as usual. I guess technically what could we do if we were really gluttons for punishment? Yeah, that's what we're going to do. But if we really wanted to do this all the way out, what could we do now? Couldn't we cross off all the C's? And then finally, D wins an election. A shutout. So we'll just say D wins fourth. Good? So the order in this case, A, B, C, D. Was that the same as the order on the previous page for the extended plurality method? A, B, C, D. No. So which one's better? I don't know. I'm just saying it's different, right? How you count the votes can change the outcome. All right, let's take a look at this next one. Recursive pairwise comparisons. Okay, first we have some good news. The calculations that we did before are still valid. So AB, AC, AD, CD, and can somebody just remind me of these numbers? A and B was, okay, and the next one was also 10, 15, and then, okay. BD?
18 or 14, 11.
CD was 18.7. Okay. Somebody just confirm that, do we have all 6 of those right? Good? Okay. So, we count the votes, the points, just like we do before. That's exactly the same as before. How many points did A have? Just 1. I think A only beat D, of course, and B had 3. C got 2, and then D got 0. Okay, so we have our first winner. Who wins? Okay, so B wins by having the most points. B is in first. Great. Now we're going to re-vote. What do we have to do? We got to cross off all the B's, right? B is now not part of this election. But there's good news here. And the good news is this. When you cross off B, for example, AC is still one of the head-to-heads that we care about, right? We cross off B, so this AB doesn't matter anymore, but AC matters, right? What's the score, A versus C, after we cross off B? It's still 10-15, right? Like B, it didn't matter that B was here or not here, right? A versus C is still 10-15. Doesn't matter who you cross off in that big table. Agree? So the good news is you don't have to recount everything. You can actually just go around here and get rid of anything with a B in it. And now we're going to give points based on what's left. So we've got A and C and D. Yeah, and so we're going to give points on only those 3 remaining head-to-heads. So who gets the first point? C gets that one. Who gets the next one? A, and then C. So the points are now 1 for A, 2 for C, 4 D. When you say it stayed the same, Tim, what do you mean?
B won all of them.
Yes, that's right. It doesn't necessarily happen that way. So yeah, I think what's going to happen is that the ranking we get here, I think, is going to be the same as you know. All right, so B was first, right? Because they had the most, and so I feel like that's first, and that's second, and that's going to be third, and that's going to be last. And that's what's going to happen here. But it doesn't always happen that way. Suppose that, suppose just for a second that we look at this one right here, B versus C. Suppose that B is the winner, you know, like that doesn't change. But suppose that this actually is reversed, that actually C beats B, all right? Just suppose that for a second, that C gets a point for that election. When I cross B off, what happens to C's score? It goes down, right? If C gets a point for this election for beating B, and then we cross B off because they won, well, that doesn't help C, that hurts C, because C had a point for beating B. And so actually some of the scores could go down just because they beat somebody that won, that is actually out of the competition. So yeah, this one I think is going to be a little bit silly because it's going to give us the same ranking we had before. It's not always that way. So let's just keep going here. Who wins the next position? I'm still A, C, and D. Sorry, so C wins second. And that means we get to cross off who? We cross off the C's, so we cross off that one diagonally, that one diagonally. All that's left is one head-to-head between A and D. Who gets the point? A, of course. So A versus D, A gets one. D is, well, you give D credit for being consistent. And so A wins third, and D wins fourth. Okay. Any questions so far? Oh, by the way, the word recursive, what does recur mean? To happen again and again. We have to run the election again and again. That's why we call it recursive. All right. The last recursive one we're going to talk about is this recursive plurality with elimination. But before we do, let's jump down here to this. We could do Borda. We could do Borda. We're not going to do Borda because it takes a million years to do Borda. But we come down here, and this is from the previous page. This is what you guys already had filled in. So who wins the election with the Borda points? The C. C has the most Borda points. So C wins first place, right? Now, when we run the election again, are we just going to get the same numbers? A will still have 59 points, and B will still have 68, and the answer is no. Why? Well, yeah, by getting rid of a candidate, the number of points you get for first place changes. How many points was each first place vote worth initially? It was 4. Okay, great. C is the winner. C is going to be eliminated because they already won. But now there's only 3 candidates. So how many points is each first place vote worth? Only 3. All of the numbers change. So it's going to give you something very different than what we've got up here. You can see why I don't want to do it again. Every time you eliminate somebody, you have to do a starting from scratch Borda count. It takes a while, but I think we get the idea that the points all change because you're crossing candidates off. All right, so I'm just going to put it out there. This recursive plurality with elimination is really tricky. You're not going to like it. If you have tomatoes, you might throw them up here at me. I don't know. But I'm just trying to put it out there so that to try to lessen how angry you are with this method. I'm just warning you ahead of time. This is not going to make you happy. The good news is I promise you I'm not going to put one of these on the test. This one. You're going to see maybe one of those 2 that's up above. You might see something from the previous page. I'm only knocking this one out of contention, okay? Melissa. Yes. Yes. We didn't have a tie. I won't, okay, if on the test there's a tie, it's perfectly fine to say A and B tie. You don't have to decide how to break a tie. Yeah. And even if it's a and B tie for second, that's a perfectly good answer, okay? All right, so just to be clear again, I'm not going to ask you recursive plurality with elimination on the test, but everything else from today is fair game. All right. And before we jump into that one, let's just take a look at a little bit about this guy, because like I said, at the end of this method, you're going to want to leave here and not look at me for 5 days. So let's jump to here, and then we'll go back to the thing that I'm trying to avoid doing. All right, so a little info on our boy Kenneth Arrow. We're going to Greg, number 12. Shh. Okay, so that's the basic idea of all the recursive methods. Can we go to Haley for 12? Mm-hmm. Okay, don't ask me what that means because I don't know, but I'm just showing you that, the person who came up with this crazy theorem that said there's no way to count the votes that will always satisfy all of the fairness criteria, he was doing some high-powered stuff. This wasn't just like, oh, I'm just going to write this little paper and then I'm going to go on and do my regular job, which has nothing to do with math and economics. But he was really, really, I say was, he is a really, really high-powered researcher. He's still alive and well. And I just want to point out that I'm guessing that most of the math that you guys have learned, elementary school, middle school, high school, college, most of it was stuff that was created thousands of years ago. Arithmetic and algebra have been around for thousands of years. Arrow's impossibility theorem is about 50 years old. I'm not saying it's, 2 years ago, but I'm saying this is a lot more current than probably just about anything else you've seen in a math class. And I think it's kind of neat that there's accessible stuff that has happened recently as opposed to studying X's and Y's and Z's, which they were doing, 15, 1800 years ago. Okay, so I think we've delayed enough. Let's try this recursive plurality with elimination. All right, the first time you do it, you run through and find your winner the normal way. So first, let's get rid of some of this stuff. I need to start over in this. We're going to do a lot of eliminating here. Okay, so plurality with elimination. Who was the winner from the previous page? So looking at the previous page with the plurality with elimination, we had C was the winner, right? It took a while. We had to eliminate. First, who did we eliminate? We eliminated D. And then who did we eliminate? B. And so I'm guessing, I don't know if I crossed them off up here. No, I didn't. But probably we would have crossed off D and then counted, and then crossed off B and then counted, right? And so we'd have these people crossed off. And so who is the winner? It's C. C wins. We take them out of the election because they won, right? We're going to do this recursive thing where we run the election again. We remove C from the election, but we're removing them for a very different reason than we crossed off the other ones. We crossed off the other folks because they were eliminated for having not enough votes. We crossed off B and D, or whoever we crossed off first, because they lost. They didn't have any chance of winning first place in this election. So now what we do is we cross off the winner because they won. Who was the winner? It was C. So we get rid of all the C's, but for a good reason. C is quite happy to be crossed off. Why are we crossing them off? Because they're in first. So this is kind of strange because it's plurality with elimination, and the eliminate part means you eliminate the losers, the people with the fewest first place votes, and then you recount. So C is quite happy to be eliminated because they won. So we start there. We'll just say from the last page, C wins first. So eliminate C. Okay, and so now we do the next round. The only candidates left are A and B and D. And this is a plurality method, so which are the only votes that matter? First place. So we're going back up to our chart. I've crossed off C because they won. It's a good reason to get crossed off. We're going to look at A, B, and D. All right, I'm going to highlight in yellow. How many, or who gets the first votes? A. Next ones? A. Next ones? B. B is blue. Next ones? D. D will be green. Next ones? B is blue. And the last ones? D. Okay, so count up first place votes. Yellow, blue, and green for A, B, and D. Okay, so we're coming down here. We count the votes, 10, 8, and 7. Everybody okay with that? Did A just win second place? Did they? Remember, this is plurality with elimination. You look at first place votes, you get to stop if what happens? If there's a majority. Majority was 13. Does somebody have a majority? No, we're not done. We're not ready to give out second place yet. Plurality with elimination says you have to keep eliminating the bottom people until somebody has enough first place votes. We need 13 for a majority. So we are going to eliminate who? D. We haven't found our winner yet. We're not done with round 2. It's really weird. Who did we eliminate first? C, because they won. Who are we eliminating now? D, because they suck.
But if C didn't have majority vote, we wouldn't have eliminated C.
Well, we actually, there's a lot of work that's hidden in this phrasing over here. When I say C wins first place, we went through it all before, right? We eliminated B and we eliminated D, and eventually A didn't have enough votes. So we eliminated all of these guys, A, B, and D, but then they come back because they have to try again for second place. So we're eliminating D. So we're going to come up here. I'm going to eliminate D. So we're going to get rid of these, and we're going to get rid of that. We're going to get rid of that. And I'm going to eliminate D in this way. You can cross them all off if you want. I think those are the only ones that'll matter. But the reason I'm doing that as opposed to the big blue scratching out is why? D is going to have to come back. I know. What we're trying to accomplish right now is awarding which place? Second place. That's all that I want to do right now. I don't get to stop until somebody has a majority. 10, 8, and 7, there's no majority yet. I need to eliminate. That's what plurality with elimination says. That has nothing to do with this recursive or extended. It's just we're trying to find the winner. The winner of second place in this case. And we're not done. Plurality with elimination says you don't stop until you have a majority. So D needs to go away, but it's only temporary. So I'm just giving D a little line through them because they are going to come back in the hopes of winning what? They're going to try to come back and win third once we find our second place winner. So it's like temporarily, and Patty's already judging D. So this is just a temporary elimination. They're going to come back for round 3. But we got to give out some more votes. So let's take a look at right here. 4 votes. Who gets them? That's now B. So we'll make that blue. And then the last one is 3 votes. Who gets those? Also B. Okay, count those first place votes up. Score? 10 to 15, right? A has 10. So we've eliminated. We get A has 10 and B has 15. Do we get to stop? Yes, somebody has a majority, more than 13. B has a majority. So by having a majority, B wins. And what do they win? Second place. B is our second place winner. So who's left? A and D. Oh, we have to run another election. And to run another election means we need A and D to be in the game. So I want A and D to be in the game. Let's put them in the game. Oh, undo, undo. There. Okay, so we're getting rid of all this stuff. We've got D coming back in. We've got A is still there. And one more thing needs to happen before I'm ready to tally, although Patty feels pretty confident about D's chances here, so we're getting rid of them. Yeah, so by winning that election, I'm sorry, I just have to get rid of some stuff here. Okay, so we've got this. Everybody's back in the game. C has already won first place. Who is about to get canceled for a good reason is B. B just won second place, so they're out of there, but they're happy to be out of there. So all that we have left is A and D. And so we count first place votes looking at A and D. All right, let's write down the score and then we'll call it a day. So here we are, last round. What's the score between A and D? A has 14, D has 11. So did me telling you it was going to be bad, did that help? Did that lessen it at all? Yeah. All right, like I said, that's not on the test. Everything else is fair game. See you guys Tuesday.